So I hope everyone is doing good. In today's video, we'll discuss about bearings in surveying subject. Okay, so coming to bearings, bearing is nothing but angle. Okay, angular measurement. And in bearings, we have two types. First one is whole circle bearing system, and other one is quadrantal bearing system. Okay, coming to whole circle bearing system, this angle ranges from 0 to 360 degrees. Suppose you can take as 220 degrees. Okay, um, and coming to quadrantial bearing system, so these in this system the angle ranges from 0 to 90 degrees. Okay, so which means the maximum value of any angle in quadrantial bearing is 90 degrees only. And again in quadrantal bearing we'll also mention the directions. Okay, so suppose north 30 degrees east or south 30 degrees west. Okay, in this way we'll designate the angles starting from north or south, and here it becomes east or west. Okay, so it depends on which direction the angle is near to which direction. Okay, so we'll discuss briefly. And before going into this, so if we take this quadrants like this, so this theta 1 is belongs to first quadrant, theta 2 and theta 3 and theta 4. So you will be given some angles in which they will be like theta 1, theta 2 and theta 3 and theta 4 as I have shown. Okay, so and coming to numericals, you have two models in this which include, so you will be given an angle in whole circle bearing system, and you are supposed to convert this whole circle bearing system angle into quadrantial bearing system, and vice versa. You will be given quadrantial bearing angle and you are supposed to convert this angle into whole circle bearing system angle. Okay, two types of numericals are there. So first we are discussing about quadrantal bearing system. Okay, quadrantal bearing system. Okay, I have taken the quadrants like this. So theta 1, theta 2 and theta 3 and theta 4. So theta 1, this is from north to east. Okay, so this theta 1 belongs to first quadrant. Okay, so here you have to know the which quadrant belongs, what is first quadrant and what is second quadrant and what is third and fourth. Okay, so this is your first quadrant, this is your second quadrant, third quadrant and fourth quadrant. Okay, so first one angle is theta 1. So I will designate this theta 1 in quadrantial bearing system as north theta 1 to the east. Okay, so I'll mention directions also in quadrantial bearing. Coming to theta 2, so this will be designated as south theta 2 east. Okay, yes, theta 2 e. Coming to third angle theta 3 in third quadrant, so that will be designated as south theta 3 west. Okay, south theta 3 west. And coming to fourth angle theta 4, this will be written as north theta 4 west. Okay, so with respect to north or with respect to south, you will start the direction and end with respect to east or west. So suppose if you take theta 1, so it is nearer to north, so I am starting to north. Suppose if I take theta 2 angle, so it is nearer to south direction, so I am starting theta 2 with direction south. Okay, in this way we will designate the angles in quadrantial bearing. And I already said the maximum angle in quadrantal bearing is 90 degrees, which means the maximum value of theta 1 to theta 4 angles is at most 90 degrees only. Okay, suppose if you consider a problem in quadrantial bearing to whole circle bearing system. So quadrantial bearing angle is given as north 78 degrees east. Suppose take this way. So first you designate this angle in which quadrant it belongs. Okay, So I have taken this quadrant system, and northeast, this falls under first quadrant system. So this theta 1 angle 78 degrees from north. Okay, so I have taken from north 78 degrees, so north 78 degrees east. Okay, so this I have taken, and I have to convert this angle into whole circle bearing system angle. Okay, so I am taking a tabular form here, so in which first one is quadrantial bearing angle, and quadrant in which it belongs, that is q1, q2, q3, or first quadrant or second quadrant or third quadrant or whatever it is, and whole circle bearing formula and whole circle bearing angle, WCB angle. Okay, so coming to first one, I have given a quadrantial bearing angle as north 78 degrees east. Okay, so when I come to northeast quadrant, which means it belongs to first quadrant. Okay, so from north 78 degrees. Okay, so coming to whole circle bearing system, and the first quadrant angle is similar with quadrantial bearing also. Okay, so this 78 degrees remains, or this theta 1, so this belongs to first quadrant, so this theta 1 78 degrees angle remains theta 1 only. The WCB angle is 78 degrees. Okay, okay, now I have taken an angle in second quadrant for quadrantial bearing system. Okay, so second quadrant belongs to southeast, so suppose I have taken south 40 degrees east. Okay, so which means your angle is this way, so this is your 40 degrees south, 40 degrees east. Okay, so but your whole circle bearing angle becomes this thing, so this is your angle for whole circle bearing system. So here I'll get whole circle bearing as 180 minus 40 degrees, that is 140 degrees. Okay, so coming to second quadrant, your whole circle bearing angle becomes 180 minus theta 2. Okay, so in quadrantial bearing you will get as NE, SE, and SW and NW. Okay, this depends on directions. Okay, now I have taken another angle, third quadrant, which falls in third quadrant. So third quadrant means south west, so I have taken south some 80 degrees west. Okay, so your angle becomes, so when you take this 80 degrees, so it falls like this, so this is your 80 degrees. Coming to in whole circle bearing system, this angle is this is the entire angle. Okay, so from here to here. Okay, so how I'll get this angle? 180 plus 80. Okay, so my WCB angle becomes 180 plus theta 3. So 180 plus 80, that comes to be 260 degrees. Okay, now coming to last quadrant, fourth quadrant. So I have taken an angle, fourth quadrant. So north 50 degrees west. Okay, so this angle is this thing, so 50 degrees. Okay, but this angle in whole circle bearing is from here to here. Okay, so this entire angle. So how I will get this angle in whole circle bearing system? So that is nothing but, so this falls under fourth quadrant. So this theta in whole circle bearing system I will get as 360 degrees minus theta 4, which means 360 minus 50. So that I'll get as 310 degrees. Okay, so this is the procedure. We will convert quadrantial bearing angle into whole circle bearing system. Okay, so in quadrantial bearing system we have this northeast, southeast and southwest and northwest directions. So depending upon these directions, we will designate in which quadrant the angle falls, whether it falls in first quadrant or second quadrant or third quadrant or fourth quadrant as well. Okay, so if your angle falls in first quadrant, then WCB angle remains same. The theta 1 in quadrantial bearing angle system remains theta 1 in whole circle bearing system also. If this theta 2 falls in second quadrant, then your WCB angle becomes 180 minus theta 2. Okay, so 180 minus 40, I have got the whole circle bearing as 140 degrees. And again, if theta 3 falls in third quadrant like south 80 degrees west, so my whole circle bearing angle becomes 180 plus theta 3. So 180 plus 80, 260 degrees. And last one, if my quadrantial angle falls in fourth quadrant, that is in northwest direction, north 50 degrees west, so my whole circle bearing angle becomes 360 minus theta 4, that is 360 minus 50, so it has come as 310 degrees. So this is the procedure. We will convert quadrantial bearing angle into whole circle bearing angle. So now we are considering second thing, that is converting from whole circle bearing angle into quadrantial bearing angle. Okay, so we'll take four different angles. First angle being in first quadrant 70 degrees, so 140 degrees it falls under second quadrant, and the third one 210 degrees, it falls from 180 to 270 degrees quadrant, and fourth one has 300 degrees angle, so this falls in fourth quadrant. Okay, now so you are given whole circle bearing angle as 70 degrees. Now you are supposed to convert this into quadrantial bearing angle. So this 70 degrees falls in first quadrant. So which means, so this is the angle given to me, 70 degrees. Okay, so your quadrantial bearing angle also remains same for first quadrant. Okay, so if first angle is 70 degrees, so this falls in first quadrant, so this theta 1 remains same, theta 1, so 70 degrees same I am writing, and so I have to show the directions. So first quadrant directions are north east, so this becomes north 70 degrees east. Okay, this is first thing. And coming to second one, 140 degrees. Okay, so this 140 degrees second one falls in second quadrant. Okay, so here to here 90 degrees and 140 will get somewhere here. Okay, so this is 140 degrees in whole circle bearing system. So I have to convert this 140 degrees into quadrantial bearing angle. Okay, so this 140 degrees falls in second quadrant. Coming to theta, so this is quadrantial bearing angle. So how I get this? Total 180 minus 140, which means 180 minus WCB angle. So this becomes 180 minus 140. So I'll get this as 40 degrees. So coming to second quadrant, the directions are southeast. Okay, so south 40 degrees east. So this is my angle in quadrantial bearing system. So I have given this angle I have got as 40 degrees. Okay, so that's the thing. And coming to third one, that is 210 degrees 210 degrees. Okay, so this falls under third quadrant. So 210 degrees, so here to here it's 180 degrees, here to here 180 degrees, and 210 it falls somewhere here. Okay, so this is the angle in whole circle bearing system. Okay, 210 degrees. Okay, now I am supposed to convert this into quadrantial bearing system. So how I get this angle? So it is this WCB angle minus 180. Okay, so that becomes WCB minus 180 degrees. So I'll get as 210 minus 180, so that is 30 degrees. So coming to third quadrant, directions are southwest. So south 30 degrees west. Okay, now coming to fourth one, so 300 degrees. Okay, so up to here 270 degrees, so somewhere I'll get 300 degrees angle like this. So this is 300 degrees. So now I am supposed to convert this 300 degrees whole circle bearing angle into quadrantial bearing angle. So which means this is the angle in quadrantial bearing. So how I get this angle? So it is very simple. So entire angle is 360. So if I subtract this whole circle bearing angle in 360 degrees, that means this angle becomes 360 minus WCB. Okay, so 300 degrees falls under fourth quadrant. So my angle becomes 360 minus WCB. So 360 minus 360 minus 300 degrees, so that comes 60 degrees. And coming to the directions, so this falls in fourth quadrant, so northwest. So my quadrantial bearing angle is north 60 degrees west. Okay, so in this way we can convert these angles from quadrantial bearing to WCB and WCB angles to quadrantial bearing angles. Okay, thank you.